See, so to start the topic, eigenvalues and eigenvectors. Okay, eigenvalues and eigenvectors. So it's a very important one. See, what is eigenvalues and eigenvectors of a matrix? See, let A be a square matrix, then a non-zero scalar lambda is called the eigenvalue if there exists a vector x. Here this x is a column vector. Remember, I already given the definition of column vector. This x is a column vector. Okay. So such that ax equal to lambda x. Okay, ax equal to lambda x, where x is called the eigenvector. This x is called the eigenvector and lambda is called the eigenvalue corresponding to the eigenvector x. Clear? So this lambda is called the eigenvalue. So it is a non-zero scalar and this x is a column vector. Okay, clear? This x is a column vector. So see here. So that means x is like in this a v1, v2 up to vn. Dow I like it in raw, but it is a what? Column vector. Now see what you got. This x equal to this one. So you got ax equal to lambda x. Okay, ax equal to lambda x. So ax minus lambda minus, if it comes to the left hand side, then it will be minus lambda I x equal to 0, where I is the identity vector, sorry, I is the identity matrix and x is a column vector. Vector means it is also a column matrix. So you already know that if you multiply any matrix with the identity matrix, then the result is again the same matrix. So that's why we can multiply x with I. Okay. So now from here, what we can take common? We can take common x. Then what is left? A minus lambda I. Now, since x is a vector and we already considered it is non-zero, so this x cannot be equal to 0. So obviously what you got then? A minus lambda I equal to 0. A minus lambda I equal to 0. Someone is still waiting. A minus lambda I equal to 0. Clear? So remember this lambda is the values. Okay. Now see here. Characteristic polynomial. So the determinant a minus lambda I when expanded will give a polynomial. The determinant a minus lambda I when expanded will give a polynomial, which is called the characteristic polynomial of matrix A. Okay, so this a minus lambda I is called the characteristic polynomial of this matrix A. Now see here. So this is an example. See here. So for the matrix A equal to, for the matrix A equal to this 2 2 1 1 3 1 1 2 2. So now determinant of A minus lambda I. So this lambda is a constant and this is the vector A minus lambda. I is the what? Identity matrix, this one. Okay, I is the identity matrix. Then what you got? This is 2 minus, this is 2 minus lambda into 1. So it will be 2 minus lambda. Next 2 minus lambda into 0. So obviously it will be only 2. Again 1 minus lambda into 0. So it will be also 1. Okay. Next, see here 1 minus lambda into 0. So it will be also 1. Again 3 minus lambda into 1. That means it will be 3 minus lambda. 3 minus lambda into 1. So it will be 3 minus lambda. Again, this is 1 minus 0. So it will be 1. Same way it will be 1, 2. And last one is 2 minus lambda into 1. That means it will be 2 minus lambda. Okay. It will be 2 minus lambda. Now, when we expand along first row, what you got? 2 minus lambda. 2 minus lambda into, this is 3 minus lambda into 2 minus lambda. 3 minus lambda into 2 minus lambda. So if you multiply this, see here what you got? 3 into 2, it will be 6. Again 3 into minus lambda. So it will be 3 into minus lambda, it will be minus 3 lambda. Again minus lambda into 2. So minus 3 lambda minus 2 lambda, it will be minus 5 lambda. Again minus lambda into minus lambda, it will be plus lambda square. Plus lambda square. Again from here what you got? Minus 2 into 1. So it will be minus 2. Okay. Next, minus 2 into what you got? 1 into 2 minus lambda. 1 into 2 minus lambda. So it will be what? 2 minus lambda minus 1 into 1. So it will be minus 1. Okay. Now plus 1 into 2, 1 into 2. So it will be 2 minus 1 into 3 minus 3. Again minus minus, it will what? Plus. So as a whole, if you simplifying this, we got minus lambda cube plus lambda square minus 11 lambda plus 5. That means we got a polynomial in lambda. We got a polynomial in lambda. And this polynomial is called characteristic polynomial of this matrix A. Okay, characteristic polynomial of this matrix A. Now again see the definition, see what I have given. The determinant A minus lambda I, when expanded, will give a polynomial which is called the characteristic polynomial of matrix, which is called the characteristic polynomial of matrix A. And this is your characteristic polynomial of the matrix. Okay. So next come to the point. Characteristic equation. Characteristic equation.